So here are some competency-based questions on integration, class 12 mathematics. Let's start with the first one, integrate integral 3x plus 1 root 2x minus 1 dx. So we write 3x plus 1 as a into 2x minus 1 plus b. So when you open the bracket, you get 3x plus 1 is 2ax minus a plus b. Coefficient of x on the left hand side is 3. Coefficient of x on the left hand side is 2a, so a is 3 by 2. Constant term on the left hand side is 1. Constant term on the right hand side is minus a plus b. So minus a plus b is 1 or b is 5 by 2. Now substituting back here, you get 3x plus 1 is 3 by 2 into 2x minus 1 plus 5 by 2. And now you multiply by root 2x minus 1. So you get 3x plus 1 into root 2x minus 1 is 3 by 2 into 2x minus 1 root 2x minus 1 plus 5 by 2 root 2x minus 1. So this becomes 3 by 2 2x minus 1 raised to 3 by 2 plus 5 by 2 2x minus 1 raised to half. And now integrate. So I becomes 3 by 2 integral of 2x minus 1 raised to 3 by 2 plus 5 by 2 integral of 2x minus 1 raised to half. That would be 3 by 2 2x minus 1 raised to 5 by 2 by 5 by 2 into derivative of 2x minus 1, that is 2, plus 5 by 2 2x minus 1 raised to 3 by 2 by 3 by 2, derivative of 2x is 2. So simplifying, you get it as 3 by 10 2x minus 1 raised to 5 by 2 plus 5 by 6 2x minus 1 raised to 3 by 2 plus c. The next is similar to this but slightly different. Evaluate integral x plus 2 by root 3x plus 1 dx. So again I write x plus 2 as a into 3x plus 1 plus b, and x plus 2 will be 3ax plus a plus b. Coefficient of x on the left hand side is 1, on the right hand side is 3a. So 3a is 1 or a is 1 by 3. Constant term on the right hand side is a plus b. Constant term on the left hand side is 2. So a plus b is 2. So simplifying, you get solving both together, you get b is 5 by 3, and now you substitute here. So x plus 2 equal to 1 by 3, 3x plus 1 plus 5 by 3, and then you divide by root 3x plus 1 and then integrate. So this becomes integral x plus 2 by root 3x plus 1. This is 1 by 3 integral root 3x plus 1 dx plus 1 by 3 integral 3x plus 1 raised to minus half dx. So what is integral of root 3x plus 1? 3x plus 1 raised to 3 by 2 by 3 by 2 into derivative of 3x, that is 3, plus 1 by 3 integral of 3x plus 1 raised to minus half is 3x plus 1 raised to half by half into derivative of 3x, that is 3, plus c. And finally, when you simplify, you get the answer as 2 by 27, 3x plus 1 raised to 3 by 2, plus 10 by 9, 3x plus 1 raised to half, plus c. The next question uses the substitution method. Integrate x minus 1 by x into x minus log x dx. So you can divide by x, so it becomes 1 minus 1 by x into 1 by x minus log x dx. So I'll make a substitution, put x minus log x as t. So when I take the derivative, what do I get? 1 minus 1 by x dx is dt. So substituting, you get integral dt by t. And this becomes log mod t plus c because this is t and this is dt. And now substitute back for t. So it is log mod x minus log x plus c. The next is a little tricky, but again using the substitution method. Integrate dx by a plus b e raised to x. So you can write this as dx by divide numerator and denominator by e raised to ex. So dx by e raised to x by a e raised to ex plus b dx. And this is integral e raised to minus ex dx by a e raised to minus ex plus b. Now put a e raised to minus ex plus b as t. So what will be the derivative? A e raised to minus ex into minus e dx equal to dt. So e raised to minus ex dx is minus dt by ae. And now substitute here, so I becomes integral minus dt by ae into t. which is minus 1 by AE log mod t plus c, and now you substitute for t as a e raised to minus ex plus b plus c. Okay, coming to the next question, evaluate integral x cube minus x by x raised to 4 minus 1 dx. So we can take out x and you can write it as x into x squared minus 1. By x raised to 4 minus 1, I can factorize as x squared plus 1 into x squared minus 1 dx. So x squared minus 1 cancels and you get integral x by x squared plus 1 dx. Now make a substitution, put x squared plus 1 as t. So 2x dx equal to dt, or x dx is dt by 2, and now substituting here you get integral dt by 2t, which is half log mod t plus c, and now substitute for t. What is t? X squared plus 1. So it's half log mod x squared plus 1 plus c. Evaluate integral x raised to 4 minus x by x raised to 5, and the numerator is raised to 1 by 4 dx. So this is slightly tricky. You take out x raised to 4. So what will this become? X raised to 4 into 1 minus 1 by x cubed, the whole raised to 1 by 4 by x raised to 5 dx. Now removing the fourth power, this becomes integral x by 1 minus 1 by x cubed raised to 1 by 4 by x raised to 5 dx. And what is x by x raised to 5? It's 1 by x raised to 4. So it's 1 by x raised to 4, 1 minus 1 by x cubed raised to 1 by 4 dx. Now put 1 minus 1 by x cubed as t. So what is derivative of this? Minus 3 x raised to minus 4. And the minus goes. So 3x raised to minus 4 dx is dt. So dx by x raised to 4 becomes dt by 3. What happens when you substitute here? You get integral dt by 3, and this becomes t raised to 1 by 4 dt. And what is integral t raised to 1 by 4? T raised to 5 by 4 by 5 by 4. So simplifying and substituting for t, you get the final answer as 4 by 15, 1 minus 1 by x cubed raised to 5 by 4 plus c. Coming to the next question, integrate 2x squared plus 1 by 9x squared plus 5 dx. Here, degree of numerator is equal to degree of denominator. So we do long division. If I do 2x squared by 9x squared, it's 2 by 9. So multiplying, you get 2x squared plus 10 by 9, subtract. Remainder is minus 1 by 9. So we have numerator by denominator is quotient, that is 2 by 9, plus remainder by denominator, and then integrate. So integral of this will be integral 2 by 9 minus 1 by 9 integral 9x squared plus 5 dx. I can take out 9 here. So you get 2x. This is integral 2x. Integral will give you 2x by 9 minus 1 by 9. If I take out 1 by 9, I get integral 1 by x squared plus 5 by 9 dx. That is x squared plus a squared. What is x squared plus a squared? Tan inverse 1 by a tan inverse x by a plus c. So this is 2x by 3 minus 1 by 81. 1 by a will be 1 by root 5 by 3. Tan inverse x by root 5 by 3 plus c. So this is 2x by 9 minus 1 by 27 root 5 tan inverse 3x by root 5 plus c. So we have discussed a few competency based questions in integral calculus useful for class 12 maths. Thank you and stay tuned.